Good morning everyone, myself Mitandas. I am a lecturer of Polytechnic College. Now I am going to discuss the topic topographical planning. Before starting the topic, you have to know that what is planning. Planning is nothing but thinking before doing. Now let's start the topic. Planning a topographic survey. When you plan a topographical survey or planning a topographical study, the most important rule is to remember that you must work from whole to the part, keeping in mind all of the work you will need to do as you begin the first steps. Now, what is the meaning of whole to the part? Whole to the part means to divide the area to be surveyed or the area to be surveyed or the region to be surveyed by help of a number of triangles or number of blocks. Now different types of survey require different type of accuracy level, but if you should lay down the first point of each survey, then accuracy is higher or higher accuracy can be possible. You will adjust all the work you do later to agree with these first points. For example, you need to plan survey a fish farm site. For that, what we have to do? At first, you must make a perimeter survey, that is ABCDA. Let's take a look. Here ABCDEA is the perimeter of the survey. Now, beside these summits and boundaries at several major points and lines such as AJ and EO. Let's take a look. AJ and EO are the major lines and they crosses each other at right angles or 90 degree. Now they run across the interior to create right angles, which will help you in your calculations. This is okay. This is your process or survey work. This survey gives the primary survey points. That means this survey will give you the primary survey points or known as control points, which you should determine and plot very accurately. Now, second point, then lay out minor lines such as FP and TN. Let's see the figure number 2 here, FP and TN. Okay, FP and TN are the minor lines. Now, they go between the major lines to divide the real number of blocks. Major lines means here AJ is the major line, EO major lines, okay, and TN is the minor line, FP are the minor line. They divided this area into a number of blocks. These are the number of blocks. Number 3, finally, survey details of each block. Each block means TNOB is a block, ONCR is a block, like that. Finally, survey details in each block using tertiary points for which less accuracy is also acceptable. Here, what are the tertiary points? M, H, S, R, Q, N, like this. Okay. Let's discuss introduction of topographical map and plans. Here, these are the two figures. First figure is plan and the second figure denotes map. Now, for example, an engineering plan could show information you need for building fish farm features such as dikes, ponds, canals or outlet structures at the scale of 1 centimeter for 25 meter, that is RF is equals to 1:2500. Second point, a topographical map could show a fish farm site of scale 1 centimeter for 200 meter, that is RF is equals to 1:20,000, or a region of a country of scale 1 centimeter for 1000 meter, that is RF equals to 1:1 lakh. Here RF 1:1 lakh means 1 centimeter of map represents 10,000 or 1 lakh meter on the ground. Okay, or you can say 1 centimeter for 200 meter represents RF is 1 is to 20,000. That is 1 centimeter of map represent 20,000 centimeter on the ground or ground surface. Now, plans and maps have two main purposes in fish farm constructions. They are, first one, they help guide you in choosing a site, planning for the fish farm, designing the structures and they are needed for the farm. Second is, plans and maps are also guide you as you lay out marks on the ground so that you can follow the plan you have made of the fish farm and build the structures on it correctly. Okay. Again, before you begin a topographical survey, you should try to get any available topographical plans and maps of the area, even though they may not exactly the kind of plan of map that you need. Generally, topographical maps are available by governmental organizations which are responsible for geographical survey or geological survey or land survey, etc. Suppose, for example, National Geographical Institutes, soil survey departments and agriculture development agencies can also usually provided existing topographical maps. Cadastral department can provide cadastral map which shows the boundaries of villages, cities, etc. Now, on topographical plans and or maps, you should always look for the name of the area of the land has been mapped. Second point, type of project. Third point, exact location of the land portion which is to be surveyed. Next point, the name of the people who made surveys on which the plan or map is based on. Next point, direction of the magnetic north. Next point, scale of drawing, etc. Now, what is scale in this context? In this context, scale is nothing but distance on map divided by distance on the ground surface. These are given in the corner of the map and they are known as legend. Let's take a look on this figure, left hand figure. Here this is a legend which is shown on a map in the corner or the top corner or the bottom corner of a map. Here this is RF, or suppose you can tell this is scale. This is here is the scale. 1 centimeter equals to 500 meter means 1 centimeter on map represents 500 meter on ground. That is RF is equals to 1 is to 50,000. Here you can see this is contour interval. What is contour interval? Contour interval is nothing but the vertical distance between two consecutive contours. Okay, for a particular contour interval of a map, contour interval depends upon type of survey, type of terrain, extent of the survey and the scale of map, etc. Here you can see the true north. True north shows the north direction of any project. Okay, now let's take a look on the right hand side. That is, this is the deciduous trees, woods, marsh or swamp, rocks. Okay, these are the bridges. This is the house made of brick. Fencing, wire fencing is this. River is this. Hedges is this. Cutting is this, and orchard is this. Okay. Now we will discuss planning a topographic survey. Topography is widely used because it is used over large area or large terrain. The choice of methods for conducting a topographic survey is governed by the following factors. First is use of topographic map. Topographic survey of a large scale map should be conducted by more defined methods than the surveys for a small scale map. For example, the computation of earthwork from a topographic map, a large scale map would be required and the ground surface should be represented quite accurately. On the other hand, for estimation of the storage capacity of a large reservoir or a big reservoir, a small scale map may be used and the accuracy required may not be very high. Another example which may be cited is that of topographic survey for a bridge site. The topography in the vicinity of the river crossing should be represented more accurately than that is the areas away from the crossing. Second point is extent of area. This second point. Topographic survey of large area should be conducted by more precisely methods than those for the smaller areas. Let's take a look. Suppose this is the it is a area, okay. This is an area. Suppose this is a large area, and suppose this is a smaller area, okay. Now, topographic survey of large area should be conducted by more precise method. That is, for large area, more precise method is required, but in case of small area, less precise method is required. Okay. Control measurements for a large area require more precision as compared with those of small areas, as it is more difficult to maintain a desired precision in the relative locations of the points over a large area. Now, next point is scale of map. What is scale of map? Scale of map is the ratio between map distance and ground distance, or the distance on the surface of the earth. Okay. Let's take a look. Here 1 cm, this is the scale of map. Here 1 cm equals to 500 meter represents 1 centimeter of map represents 500 meter on ground. Okay. A map scale is chosen consistent with the purpose of the survey. The method of topographic survey should be selected considering the scale. For example, the purpose of survey will be served if the average error in measurement of distance is 1 meter for a scale of 1:4000. Because a surveyor can plot the distances to the nearest of 0.25 mm. Okay. Now, next point is contour interval. So, what is contour? Contour is nothing but line of intersection of level surface with the surface of the ground, and the vertical distance between two consecutive contours is known as contour interval. For a given contour interval or for a given type of map, contour interval depends upon extent of survey, type of terrain, scale of map, etc. Now, let's take a look. Here given contour interval equals to 1 meter. So, the vertical distance between two consecutive contours is known as contour interval, which is of 1 meter. Okay. The smaller the contour interval, the more refined should be the field methods. Now, the next point is type of terrain. Let's take a look. Okay. Suppose this is a terrain. Suppose. Okay. And here you are saying scale equals to 1 centimeter equals to 200 meter, that is representative fraction is equals to, that is RF equals to 1 is to how much? It will be 20,000. Okay. Now the field method should be selected considering the type of terrain. For rugged terrain, suppose this is the flat terrain. This is the flat terrain and this is the rugged terrain. Okay. For rugged terrain, the methods may be less precise compared to those for a comparatively flat terrain. Okay. Thank you.